In this video, I'm going to talk through the worked out solutions to final exam review number 4 for the semester 1 Algebra 1 final. When you look at number 1A, the directions say solve the equation, I know that means I need to get the variable by itself on one side. So when I look at A, I see that I have a proportion, a ratio equal to another ratio. To solve a proportion, we can do this a couple different ways. Most students in the class like to cross multiply, so that's how I will show you in this video. So we can cross multiply. I see that if I do 24 times z minus 1, that should equal 4 times 5z plus 4. And from there, I distribute 24z minus 24 equals 20z plus 16. Now I see that I have z's on different sides of the equation, so I need to get them to the same side of the equation in order to be able to eventually isolate the variable. Because this is 24 and this is 20, I'm going to subtract 20 from both sides so that I keep my variable, the coefficient of the variable positive. And when I do that, I get 4z minus 24 equals, those add to be 0, so I'm left with 16 on the right-hand side. Then I do inverse operations. I add 24 to both sides. I'm left with 4z equals 40. Divide by 4, and I get that z is equal to 10. Now, again, like we've talked about in class and in previous videos, I can check my answer. So I can do 24 divided by 5 times 10 plus 4. That equals 0.4 repeating. So then if I look at the other one, if I do 4 divided by 10 minus 1, that also, so they do equal the same thing, so we're good to go. We checked our answers. This next equation, we have x's on both sides. I see we have parentheses, so when I'm looking at this, I realize that I need to distribute first. So I have 8x minus 15 is equal to 3x minus 15 plus 5x. From there, I see I have these x's on the same side, so I'm going to combine like terms on the same side. So this guy is just going to stay the same, but then I can combine these like terms and do 8x minus 15. Well, now I have 8x and 8x on both sides, so if I subtract 8x from both sides, what I see is I'm just left with negative 15 equals negative 15, because those both added to be 0. Now, this is a true statement. All the variables are gone, so I can't solve for x, but I see that I have a true statement. In fact, that is always true. So this means all real numbers. Meaning, any number that I substitute in for x will keep this equation balanced or true. So it doesn't matter what I choose, I could choose anything and that would be true. Scooting down here, it says you ride an elevator at a hotel. The graph models your distance from the ground over time. So here's our time in seconds. Here's the floor from the ground. What is the x-intercept? Well, our x-intercept is where the graph crosses the x-axis, so that's this guy right here, 18, 0. Wants to know, what does it mean in this situation? Well, if x is time, so that's 18 seconds, y is the floors from the ground, so if y is 0 means I'm on the ground. So in 18 seconds, I'm on the ground. So it looks like I start at a certain height, and then my height is decreasing. I go down, down, down until I hit the ground. So how I would interpret this is you reach the ground after 18 seconds. The ground would be the interpretation of the y-coordinate. The 18 seconds is the interpretation of the x-coordinate. The y-intercept, well, the y-intercept is this guy up here, 0, 21, where the graph crosses the y-axis. What it means in the situation, well, that's where x is 0, y is 21. Well, x is the time, so when the time is 0, y, the floors from the ground, is 24. So what that essentially means is time being 0, that's when I start. So this means you start on the 21st floor, or you start 21 floors above the ground. Number 3 asks us to find the slope. We've talked about slope multiple times. Slope is our rate of change. It's a change in the dependent variable compared to the independent variable. It is the rise over run, change in y over change in x, all those things. But when I look at a graph, I like to do rise over run. So I'm going to pick 2 points that I can find the coordinates there. My rise is 0. I'm not rising anything, but I'm running 3 to go from there to there. And if we punch in our calculator, we'll see that 0 divided by 3 is 0. 0 divided by 3 is 0. So our slope is 0. Now some people just memorize that if this is a horizontal line, the slope is 0 because you're not increasing or decreasing. So if you're not increasing, you're not decreasing, then your slope would be 0. That's another way people can think about it. For 3B, it says it took Lance 5 hours to grade the geometry test, and he ate M&Ms while he was grading. There were 150 M&Ms when he started and only 30 when he finished. At what rate did Lance eat M&Ms? Well, rate is the change in y over change in x. It's like another word for slope. So what I'm thinking is like how many M&Ms did he eat per hour? So I'm going to have M&Ms on top, or the change in the M&Ms over the change in time. And so when I look at the change in M&Ms, well, I started with 150. I only have 30 now, which means that I decreased. So my final was 30. My initial was 150. It took 5 hours to eat all those. So it'd be negative 120 divided by 5, or negative 24. The reason it's negative is because the amount of M&Ms left is, or the amount of M&Ms left is decreasing. And our units, the top would be M&Ms per hour. Now you could interpret this at what rate did Lance eat the M&Ms? Well, if he's eating, he's not eating at a negative rate. So if you interpret this as how many M&Ms are left, that would be it's decreasing. You could also say that it would be 24 M&Ms per hour if you're talking about Lance, how much he ate. So Lance ate 24 M&Ms per hour, or the rate at which the M&Ms was, or how many M&Ms were left, it was decreasing by 24. Either way, I could see you interpreting it. Find the x and y intercepts of the function. Well, when you look at this, we see a graph, so I'm going to jump to the graph first. My x-intercept is where the graph crosses the x-axis, but when I look at this, I'm not sure where that's going to be, so we're going to have to come back to that. But the y-intercept is where the graph crosses the y-axis, and we can see that right there. It's at 7. We also are given an equation, y equals x plus 7, and I see that the if that's y equals mx plus b, slope-intercept form, the intercept is 7. So going back to the x-intercept, I can't see it on the graph, but I do have the equation, so I could substitute 0 in for y because I know the x-intercept has a y-coordinate of 0, and then I could subtract 7 and I get the x-intercept is negative 7 comma 0. Another way that you could do that is to make a table, find all these points. So if I were to make a table, here's your x, here's your y. I have 0 comma 7, I was at 1 comma 8, 2 comma 9. If I start working backwards, negative 1 comma 6, negative 2 comma 5. I could keep working backwards until I found where y was 0, and I should get that x is negative 7. There's another option for you. Switching over here, to find the x and y intercept. X-intercept is, like we said, is when y is 0. The y-intercept is where x is 0. So I'm looking at this, I don't see zeros anywhere, so we're going to have to find the pattern in the table and extend this table. Our x-coordinates are increasing by 5 each time. Our y-coordinates are decreasing by 2. So if I continue this pattern, 10, 8, 6, 4, 2, 0. Now we got a 0. That'll be our x-intercept, increased by 5. That's 35. So our x-intercept is 35 comma 0. If I work backwards here, that's 5 and 12, 0 and 14. And now we have our y-intercept. So there's our x and our y-intercept. All right, and flipping to the back. For number 5a, it says write an equation of the function that has the following function values. Well, if the input is negative 2 and the output is negative 2, that's really the point negative 2 comma 2. Input of 4 and output of negative 8 is really the point 4 comma negative 8. So it's really like giving me 2 points. And we talked about different ways of doing this. One way is you could use those 2 points to find the slope, change in y over change in x, which would be negative 6 over positive 6, which is negative 1. If I have the slope in 2 points, I can use that slope in any one of the points and write the equation using point-slope form. So y minus y1 equals the slope times x minus x1. Notice I made them both plus because they were minus or negative coordinates. And that's in point-slope form. It doesn't tell me what form it wants. So I could just stop there, or I could get this into slope-intercept form. Y plus 2 equals negative x minus 2. And then if I subtract 2 from both sides, I get my final answer is y equals negative x minus 4. Now that's just one way. There are multiple ways. Another way is some students like to use tables. So if we have x and y, negative 2, I'd have negative 1, 0, 1, 2, 3, and when I get to 4, I have negative 8. Now, we found the slope was negative 1, so we should be decreasing by 1 each time x increases by 1. So it would be minus 3, minus 4, minus 5, minus 6, minus 7, until we get to minus 8, or negative 8. And so we see our y-intercept is there, and we could get that in our table, or for our equation as well. 5b says write the equation of a line that is perpendicular to the x-axis and goes through this point. Now I'm going to draw a picture because this is going to help me visualize what's going on. So we have x, I have y. So there's my x-axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Oh wait, no, 6. So this is a point 5, comma negative 6. I want to be perpendicular to the x-axis. So if that's the x-axis, perpendicular would be vertical. So I want the vertical line through the point 5, negative 6. Now some people memorize what the equations of vertical lines are, but some of us don't. So let's look at this. Let's find some other points here. This would be the point 5, negative 5. Maybe that's 5, negative 4. Up here, maybe that's 5, comma 5. And what we notice is all of the x coordinates remain 5, and it doesn't matter what the y coordinates are. So this equation would be x equals 5. Switching on to number 6. To graph this, we have a couple different options. We can graph using x and y intercepts. It's not in standard form, but we could get it in standard form or just find the x and y intercepts. Or we could realize that if it's just 2y, if I divide everything by 2, then I can get this in slope-intercept form. So that'd be y equals 2x minus 4. So I can plot the y-intercept of negative 4. I use the slope of 2, or 2 over 1, where I rise to run 1. And I should have an increasing function because this is a positive slope. And I'm good to go. So let's write an equation of the line that passes through this point. So I know it's that point, and I'm perpendicular to this line. Well, in order to write the equation of the line, we've talked about often you need the slope and a point at least. So here's the point, but to find the slope, we use the fact that we're perpendicular to this line. So if this slope is 5, the slope of the line perpendicular would be the opposite reciprocal, negative 1/5. So now I have a slope, I have a point, I can use point-slope form, and I can write my equation. It does not tell you what form it wants the equation, so technically I've done what it needs me to do, but if this is a multiple choice test and all the answers are in slope-intercept form, I need to be able to get the equation into slope-intercept form. So negative 1/5 x, negative 1/5 times the negative 5 is a positive 1, so I add 1 to both sides, and I get y equals negative 1/5 x plus 2. There's my answer. Now if I go to graph this, y equals, let's clear that, we take the original equation, 5x minus 2, the other equation that we just wrote the equation of, negative 1/5 x plus 2. I go to graph it. Because of my window, these do not look perpendicular. So if I want to make this window a square, we can do that. And now they look a little more perpendicular. Or if I want to zoom in, let's go down to zoom fit. We can do that. This doesn't do a great job, but if we make this square again, number 5, there we go. Now they look a little more perpendicular. But you can see where you just using the graphing calculator may not be the best tool because it may be difficult to tell whether they're perpendicular, and you need to make sure you understand how to use the windows. All right, scooching down here to number 8. Determine whether the function is a relation. Well, we know that functions, or relations are functions if and only if each input has exactly one output. And when I look here, I see the input of 3 has 2 different outputs. So no, this is not a function. This is like pressing one button and getting Coke, pressing that same button and getting root beer. It doesn't make sense. It's not a functioning pop machine. Because it's not a function, we do not need to do the domain and range. This one's asking, is the table linear? Well, we are increasing by 2 for y, and that continues, and we're increasing by 1 for x. So because this table has x and y coordinates that are both increasing at a constant rate, yes, this is linear. And again, because the x and y coordinates change at a constant rate. Alright, then finally for number 10 is asking us to find the x-coordinate of the system of equations. The x-coordinate of the system, well, it's really the x-coordinate of the solution to the system, and the solution to the system is always x comma y, but again, this is just asking for the x-coordinate, so that's what we're trying to find. I look at this system and I notice that these equations are both in standard form, so I'm thinking it might be easiest to solve using elimination. It really wouldn't be that bad for substitution though, because I just have to get that x by itself. There's no coefficient in front of the x, so I could just add 4y and solve for x and do substitution. But typically I do elimination if I see two equations in standard form. So right now, these two variables will not add to be 0. These two will not add to be 0, so we can't eliminate. So I need to multiply one of the equations, or maybe both of the equations, by a number in order to eliminate one of the variables. In other words, in order to get the coefficients to be opposites. So that's a 2. This is really like a 1. So if I multiply this bottom one by -2, I can see that the coefficients of x will now be 2 and -2, so they will be opposite. So I'm going to carry the top equation over, that's not changing, but the bottom equation will be now -2x plus 8y equals -18. And now when I add these add to be 0, so I'm left with 13y equals -13. And when I solve for y, I get y equals -1. Now it wants the x-coordinate. I know the y-coordinate, but I need the x-coordinate. So I can substitute y equals -1 into either equation. I'm going to substitute it into the bottom one. X minus 4 times -1 equals 9. This is really x plus 4 equals 9, so if I subtract 4 from both sides, I get x equals 5. So the solution to this system is this, but it wants the x-coordinate, so my answer would be 5. The x-coordinate is just 5. And there we go.